Space exploration looks simple in movies, animations, and headlines. Rockets launch, astronauts float, and missions appear effortless. But this is only the surface of the story. Behind every mission is a long list of problems that can end it instantly. Space is not just far away, it is actively hostile to human life. There is no air, no pressure, and no protection. Tiny mistakes in space can become fatal within seconds. Distance removes the option of quick rescue or repair. The farther humans go, the more space begins to set the rules. This is why space is so hard, and why exploring it is one of humanity's greatest challenges. Space is not empty. It is a deadly environment for the human body. There is no air, no pressure, and no oxygen to breathe. Without protection, a human would lose consciousness in seconds. Temperatures in space swing between extreme heat and extreme cold. There is no atmosphere to regulate or soften these extremes. Radiation constantly flows through space from the sun and beyond. Earth's magnetic field protects us. Space offers no such shield. Micrometeoroids travel at speeds faster than bullets. Even small impacts can cause catastrophic damage. In space, survival depends entirely on technology working perfectly. In space, distance is not just measured in kilometers. It changes everything. Low Earth orbit is still close enough for quick help. Beyond that, rescue becomes slow, difficult, or impossible. The Moon is already far enough to remove emergency return options. Mars is so distant that help could take months or years. Communication is limited by the speed of light. A message to Mars can take over 20 minutes to arrive. This delay removes real-time control from Earth. Crews must solve problems alone with limited supplies. In space, distance turns every mission into a test of independence. The human body evolved for life on Earth, not for space. Without gravity, muscles quickly begin to weaken. Bones lose density when they no longer support body weight. After months in space, astronauts return physically weaker. Microgravity also affects the human cardiovascular system. Fluids shift toward the head, changing pressure inside the body. Many astronauts experience vision changes during long missions. The immune system also behaves differently in space. Radiation exposure increases the risk of long-term health problems. Space slowly pushes the human body beyond its natural limits. Gravity shapes every system in the human body. In orbit, astronauts live in near-total weightlessness. This environment is completely unnatural for long-term human health. The Moon has gravity, but only 1/6 of Earth's. Mars has more gravity than the Moon, but still far less than Earth. We don't yet know how the human body adapts to partial gravity. No one has lived for years outside Earth's gravity. Artificial gravity is difficult and expensive to create. Without gravity, even simple tasks become complex. Gravity is invisible, but its absence may be one of spaceflight's biggest challenges. In space, technology is the only thing keeping humans alive. On Earth, broken systems can often be repaired quickly. In space, there is no outside help. Every spacecraft is a tightly balanced system. A failure in one system can affect all the others. Tiny issues can quickly escalate into mission-threatening problems. Space hardware must survive radiation, vibration, and extreme temperatures. Repairs are difficult, slow, and limited by available tools. There are no spare parts floating nearby. In space, engineering mistakes are often unforgiving. In space exploration, mass is one of the most critical limitations engineers face. Every kilogram launched into orbit requires enormous energy to escape Earth's gravity. More mass requires more fuel, and more fuel increases total mass even further. This creates a complex balance that engineers must calculate precisely. Spacecraft are built with extreme weight efficiency in mind. Every component must justify its mass before it is approved. Food, water, oxygen, and spare parts all add up quickly. Resupplying distant missions becomes increasingly difficult and expensive. Long-duration missions must carry nearly everything they will need. In space, every kilogram represents cost, risk, and engineering compromise. Space missions are tough not just technically, but mentally too. Long missions mean months of confinement in small enclosed spaces. There is little privacy and almost no escape from routine. Isolation increases as Earth becomes more distant. Communication delays make conversations feel disconnected. On a Mars mission, responses from Earth could take over 20 minutes. Crew members must rely heavily on each other. Tension in confined environments can escalate quickly. Monotony and repetition can affect focus and decision-making. In deep space, mental resilience becomes as important as engineering. Space exploration does not move at the speed of headlines. Major space programs take decades from concept to launch. Rockets must be designed, tested, redesigned, and tested again. Every component is inspected under extreme conditions. Failures are studied carefully before moving forward. Budget cycles and political changes slow development further. Unlike software, rockets cannot be updated overnight. Each launch represents years of preparation. Progress in space is measured in decades, not months. In deep space, mental resilience becomes as important as engineering. Space programs do not exist outside politics. They're funded by public budgets approved on Earth. Every major mission competes for limited financial resources. Changes in leadership can redirect entire programs. Some missions are delayed not by engineering but by funding. International cooperation can accelerate progress. But global partnerships also require complex agreements. Commercial companies now play a larger role in spaceflight. Private investment brings innovation but also financial risk. In space exploration, progress depends as much on Earth as it does on the universe. Even with the risks and costs, we just can't stop exploring space. Exploration has always carried risk. Every major step forward required patience and resilience. Space makes us tackle problems we can't overlook. It pushes science, engineering, and human endurance. Many technologies we use today were shaped by space research. Exploration expands not only our reach, but our understanding. It reminds us how small we are in the universe, and yet it shows what humans are capable of achieving together. Space is hard, but exploration is part of who we are.